Hello, I'm Dr. Papia Bhattacharjee. In this problem, we have a function and we have to find all the vertical asymptotes. To the curve of this function. So notice that this is a rational function. That's the first thing you should notice. And why is it a rational function? Because it is of the form a polynomial over a polynomial. And there's a very nice way of figuring out all vertical asymptotes of a rational function. So let me remind you of that first. So suppose we have a rational function f and it is written as p over q. P is a polynomial and q is also a polynomial. So when will a vertical line be a vertical asymptote to this function? And a vertical line is written as x equals constant. So we say that x equals a constant, say c, is a vertical asymptote to the function, to the curve of the function, if. So before I write down the if, think about it for a second, right? Here's a function. Vertical asymptote is a vertical line so that the function increases without bound or decreases without bound when it approaches that line. And when will that happen? When the function value is getting bigger and bigger for certain x values. And when will the function value get bigger? When the denominator will get smaller. The denominator gets small, the whole thing gets large. So it will be a vertical asymptote if when you plug in this value c to the denominator polynomial, that will be 0. But also we have to make sure that at that value c, the numerator, so when you plug into the numerator polynomial, that is not 0. So those two things will give us vertical asymptote to a rational function. Okay, so come back to our function and note that this top one is our p and this bottom expression is our q. And we will use this concept to figure out all the vertical asymptotes. So the very first thing is q has to be 0, right? So let's take the q of x, set it equal to 0 and solve for x. So what is q of x? It's x squared plus 3x, and that is 0. Okay, this is just an equation with the variable x, and let's try to solve it. Now the left hand side is a quadratic, so let's try to factor that. Notice that both terms, there is a common x as a factor, so pull out that factor x, and the first term will be left with 1x, second term will be left with plus 3. And that is equal to 0. So we have two factors equal to 0. So we get either x is 0 or we get x plus 3 is 0. And this one gives x is negative 3. So when x is 0, there is a possibility that this function is approaching to infinity without bound and for x equals negative 3. But we are not entirely sure yet. Remember the second portion we have to check as well. So let's check that. So at x equals 0, what is happening to the polynomial in the numerator, to p? So for this one, see p of 0 is 0 minus 3, that is negative 3. And negative 3 is of course not 0. Same for x equals negative 3. Let's see what is happening to the polynomial p when you plug it in. So p of negative 3 is negative 3 minus 3. So that is negative 6, which is also not 0. Therefore, we can say that both these values, okay, hold on, this is not really a value now. We have to write it as the equation of a line because this is a vertical asymptote is a vertical line, And the equations are, one of them is x equals 0 or the y-axis. So this is a vertical asymptote, and x equals -3, that's another vertical line. These are the vertical asymptotes. To the graph of this function. So we got two vertical asymptotes for this function. Thank you.